In this video, I'm going to talk about automation. Actually, we will learn about the automation, data models, and protocol information. Also, we will learn about the Yang data model with IETF and OpenConfig, along with NETCONF and RESTCONF protocols. In addition, we will learn about the model-driven telemetry and how it can be used to gather information from network devices. First, let me to introduce the network APIs and protocols. You know that in previous video we learned about the APIs. Here we are reviewing again about the application programming interfaces. Application programming interfaces, or API, are simply interfaces for software systems to talk to one another. An API has a set of requirements that describe how application can communicate between themselves. For years, users have been communicating with applications through user interfaces, or UIs, by viewing information and requesting data from the application. When a software system wants to communicate with another software system, that is where APIs come into play. However, we as users can also use APIs to talk to application just in a more software way instead of a traditional UI or user interfaces way. Also, protocols are used to transport information between the systems using NetConf and RESTCONF. We will learn about these protocols with more detail in this video. About the network APIs and protocol concept, you know that APIs can help application developers enable features that end up helping end users. For example, a mobile application such as Yelp pulls location data from Google Maps via API calls to provide list of location of restaurants for Yelp's end user. Again, this is an example of a software system that wants to communicate with another software system. As another example, Network Management System, or NMSS, communicate with Simple Network Management Protocol, or SNMP, to request and receive information from SNMP enabled devices. SOAP, or Simple Object Access Control, is a major standard from Microsoft that is used to build web service on the internet. SOAP uses HTTP to transport message using XML syntax. Also, we learned about the representational state transfer, or REST is an API framework for simple web service that also uses HTTP methods such as a get, post, or put and delete. REST is a popular due to its performance, reliability, simplicity, and scalability. Also, we know about the NetConf. You know that the Network Configuration Protocol, or NetConf, which was standardized in 2006, leverages SSH and XML-based encoding. NetConf defines the transport and communication protocol and uses Yang for data. Google RPC, or gRPC, provides a general open source framework. It is a functional subset of NetConf and uses JSON representation. gRPC, or Google RPC, also supports unstructured data using the CLI and offers high performance. About the RESTCONF protocol provides a REST-like API for a network. RESTCONF, which was standardized in 2017, supports both XML and JSON representation and uses Yang for data. About the evolution of programmability, back in 2003, RFC 3535 was published to provide an overview of a workshop held by the Internet Architecture Board, or IAB, on network management. The goal was to continue the dialogue started between network operators and protocol developers. One of the notable recommendations from the network operators and developers was that the IETF should focus resources on the standardization of configuration management mechanisms. Next, in 2006, NETCONF was defined in RFC 4741, and again in 2011, it was further defined in RFC 6241. The NETCONF protocol provides mechanisms to install, change, and delete network device configuration. Alright, now let me to explain a little about the data encoding formats. As systems communicate with each other, there needs to be a structure behind what is communicated. Simple formatted text that is presented with show commands on a Cisco device will not work. However, systems can easily parse and work with data that is encoded in XML and also JSON formats. Let me to review a little about the JSON and also XML in this video. JSON or JavaScript object notation is a lightweight data interchange text format. It is fairly easy to read and write and fairly easy for systems to understand and process. For example, take a look at the syntax that JSON uses for object and arrays. Collection name, value pair, okay, means key value pair. And then we have object, the opening curly bracket, closing curly bracket. And after that, ordered list of values include, for example, array with the opening bracket and closing bracket. Here, as you can see, we have some key value pair. This is the first key value pair and this is the second key value pair. And as you can see here, we have the simple JSON formatted text. I explained the JSON previously in the previous video. About the XML or Extensible Markup language, it is a markup language similar to HTML that was designed to store and transport data. XML is data wrapped in tags and is both human readable and system readable. For example, notice the tags used to start and end text, beginning and ending tags. Text, hello world, and then /text. Here you don't forget that you should use / before the ending tag. And also we can the option of hierarchy of tags. Start tag is tx and Houston, and end tag /Houston and /tx. Okay. This figure shows an example of XML for a gigabit Ethernet interface. As you can see, we have the tag of gigabit Ethernet and here /gigabit Ethernet, and then name, this is the for example value or a string, and this is the /name, the ending tag. Okay, IP /IP, address /address, primary /primary, and address mask /mask. This is the XML. About the XML also we learned more than this in the previous video. Alright, about a data model can be thought of as a well understood and agreed upon way of describing something. A data model describes a controlled set of data using well-defined parameters to standardize the representation of data. Let's consider an example of houses for sale. Here is a possible data model for houses for sale. For example, location, number of bedrooms, square feet, total bathrooms, lot size, property type, and also the price. This is the example of data model for selling a house. Alright, now let me to explain a little about the model-driven programmability stack. Model-driven programmability provides several advantages, including flexibility and modularity. Model-driven programmability is model-based, structured, and system-friendly. It provides support for multiple model types, from native and common to OpenConfig and IETF industry standards. Furthermore, models are decoupled from transport protocols and encoding. Model-driven APIs allow for abstraction and simplification. In this figure, the model-driven programmability stack consists of 6 layers. At the bottom are Yang data models that are both native and open. Next are 2 transport protocols, SSH and HTTP. Above, that is the protocol layer, including NetConf, RESTCONF, and gRPC. The encoding layer has both JSON and XML. The API layer is next with model-driven APIs using Yang. Finally, applications are at the top of the stack. We will further learn about several of these components in this video. Let me to review the REST. Web browsers use REST to get and post information to web servers or other systems that use HTTP. The same HTTP request method and responses code are used. This figure actually shows a create, retrieve, update, and delete crude example with the client using HTTP post, HTTP get, HTTP put, and HTTP delete calls along with the response codes coming from the servers. We learned about them previously. Okay, here as you can see we have the create, retrieve, update, and delete. We send the HTTP post. Okay, and after that we can for retrieving data we can use HTTP get, for updating data we can use HTTP put, and for deleting data we can use HTTP delete. And here we have different responses from the server. This table lists some common HTTP response code. I explained all of them previously, but for now let me to review about the success messages. Messages starts with 200 means request succeeded. 201 the request has been fulfilled, new resource created, as you can see. And 204 the server fulfilled the request but does not return a body. But also we have some error message, some error related to the client errors or the for example server errors. Alright, in this section I'm going to give you more information about the Yang, NETCONF, and also RESTCONF. Yang is intertwined with NETCONF and RESTCONF as they are all protocols used to manage configuration and state data. This table lists the Cisco supported products for Yang, NETCONF, and also the RESTCONF. Let me to review it. Look at here about the Cisco supported products. For example, iOS XR support NETCONF and Yang. NXOS support NETCONF. iOS XE support NETCONF. Tailf Network Control System or NCS support NETCONF and Yang. Tailf configured agent support NETCONF and Yang. OpenSDN controller, Open Daylight support NETCONF, Yang, and also the RESTCONF. First, I will explain a little about the Yang, after that NETCONF, and finally RESTCONF. Yet another next generation or Yang is an IETF standard RFC 6020 data modeling language used to describe the data for network configuration protocols such as NETCONF and RESTCONF. Yang is extensible, enabling the addition of new content to existing data models and new statement to the Yang language. Yang also has a limited scope. It is intended to describe network concepts in a tree structure along with data and types. Yang is intended to be very readable compared to other schema languages. Yang data model can be displayed and represented in a variety of formats, including the following: Yang language, clear text, XML, JSON, and also HTML, JavaScript. This figure illustrates the NETCONF Yang stack. A Yang module is a self-contained top-level hierarchy of nodes. A Yang module can also use sub-modules. It uses linkage statements such as import and include. As you can see here, we have module 1, and here we have import module 2, and also include the sub-module A, and also again here in the sub-module A we have include sub-module X, sub-module Y, and sub-module Z. Within a module, containers are used to group related nodes. As you can see inside of this module we have, for example, 2 containers, and within a container, lists are used to identify nodes that are stored in a sequence. As you can see here, we have in the container Y we have list, and inside the list each individual attribute is referred to as a leaf. Okay, and attributes are used for things like names or description. Each leaf also needs to have an associated type such as Boolean or for example, a string. This table lists the common attribute for leaf values. Let me to explain about it, but you know that the detail of this table is not is beyond the scope of this video. Only we are reviewing these attributes. You know that we are talking about the attributes of these leaves. Okay, inside of module we have container, inside of container we have multiple lists, and each list has multiple leaf, and now we are talking about the leaf attributes. First, about the config. This attribute specifies whether this leaf is a configurable value true or an operational value false, and is inherited from the parent container if not specified. It means that assume that you have a feature. This feature has a value, okay, and we can't configure it. Because of that, the attribute of config of this leaf will be false. But if we have an attribute that we can configure it, the config attribute will be true. The next attribute is the default. It specifies the default value for this leaf and implies that the leaf is optional. Okay, mandatory. Specify whether the leaf is mandatory true or optional false. Must. It specifies the XPath constraints that will be enforced for this leaf. About the type. It specifies the data type and range of this leaf. About the when, is indicate a conditional leaf which is present only if the XPath expression is true. Description. About the description, it provides a human readable definition and help text for the leaf. About the reference, provide a human readable reference to some other elements or a spec. Units provides a human readable unit specification, for example, hertz, megabit per second, or other specification. Status indicate whether this leaf is current, deprecated, or obsolete. When versioning Yang modules, consider the following. Add a revision number at the top, update the organization, contact, and other information. Do not rename a module or namespace. Do not remove obsolete definitions, and do not reorder data definitions. For example, in this Yang module, we have organization, and it is recommended to have revision number at the top of the module, and also we should update the organization, contact, and other information. And also we should not rename a module or namespace, or remove obsolete definition, or reorder the for example, data definitions. Yang is used to describe both device data models and service data models. The following are examples of the device data model, like interface, like VLAN, like ACL. And the following are examples of the service data model, like the layer 3 MPLS VPN, VRF, and also network ACL. Alright, now let me to explain a little about the NETCONF or Network Configuration Protocol. NETCONF is a network management protocol defined by the IETF in RFC 6241. NETCONF provides rich functionality for managing configuration and state data. The protocol operations are defined as remote procedure calls or RPCs for requests and replies in XML-based representation. NETCONF supports running, candidate, and startup configuration data store. The NETCONF capabilities are exchanged during session initiation. Transaction support is also a key NETCONF feature. This table, okay, as you can see, lists some of the key points for 3 NETCONF data store: running, startup, and candidate. Okay, as you can see in NETCONF, like the management information based in the SNMP, we have 3 types of this data stores: running, startup, and candidate. And here, as you can see, we have data stores. Target of operations may hold entire copy of the configuration. Not all data stores are supported by devices. Running config is the only required data store, and not all devices are, for example, writable. Here we can see the features or the criteria of these data stores. Let me to review it again. All of them are data stores, and all of them are target of operations, and they can hold entire copy of configuration or not all configuration. Not all data stores are supported by device. It means in all devices we don't have all of these data stores. Running config is the only required data store. Yes, this is the only required data store. Others can be available and can be not available. Not all devices are writable, means all of these data stores are not writable. Also, the left figure shows the NETCONF model, which has 4 layers, and how NETCONF detail map to it. As you can see here, we have the content layer, operation layer, RPC layer, and transport protocol. The transport protocol is SSH. The RPC can be RPC or RPC reply, remote procedure call. The operation can be get config, and also other operations, and we have notification. And the content is configuration data. NETCONF is a client server protocol and is connection oriented over TCP. All NETCONF messages are encrypted with SSH and encoded with XML. A NETCONF manager is a client and a NETCONF device is a server. Okay, the initial content of the hello message defines the NETCONF capabilities that each site support. The YANG data model defines capabilities for the supported device. In addition, other standard bodies and proprietary specification define capabilities. This figure provides an example of the NETCONF hello operation. Notice that the capabilities are listed and each one has either IETF or tailf noted to indicate whether IETF or tailf proprietary specification define the YANG data for the capability. Here we can see the capabilities, and in each of them we have IETF or tailf, a keyword that define this is the IETF capability or tailf proprietary capability. As I mentioned before, NETCONF is a client-server protocol and is connection-oriented over TCP. All NETCONF messages are encrypted with SSH and encoded with XML, okay? Because of that, here we can see the NETCONF protocol operations, which as you can see use XML-based encoding, okay? Let me to review some of them. For example, in NETCONF operations, we have get config, edit config, get schema, lock, unlock, and close session. For example, when we want to retrieve all or part of a running configuration and device operational data, we can use the get message. Or when we want to retrieve all or part of a specified configuration, we can use get config. Okay, or when we want to retrieve the device schema, we can use get schema. When we want to load all or part of the specified configuration, for example, create, merge, or replace or data, we can use edit config. Or when we want to request graceful session termination, we can use close session. Or when we want to lock the entire configuration data store that is candidate, we can use lock. Or when we want to remove the lock on the entire configuration data store that is candidate, we can use unlock. And also we have some other operations. In this for example figure, you can see that the NETCONF communication started from the manager to the agent, and here connect to the device and say hello. You know that with hello we transfer some of the capabilities that we have, retrieve capabilities. After that, investigate available models, determine which to use, and then compose operations. Get config, you know that get config is using for retrieving all or part of a specified configuration. And after that, here send message RPC, and after that retrieve RPC reply, and then we can process the data. This is the one example, but you know that in NETCONF we have multiple NETCONF protocol operations. Now let me to explain a little about the RESTCONF. RESTCONF, which is defined in RFC 8040, is an HTTP based protocol that provides a programmatic interface for accessing YANG model data. RESTCONF uses HTTP operations to provide create, retrieve, update, and delete or CRUD operations on a NETCONF data store containing YANG data. Okay. RESTCONF is tightly coupled to the YANG data model definition. IT supports HTTP based tools and programming libraries. Okay, RESTCONF can be encoded in either XML or JSON. Here is an example of a RESTCONF uniform resource identifier or URI. As you can see, /RESTCONF /resource type /Yang module and then resource. Okay, you know that the RESTCONF uses the NETCONF data store containing Yang data. RESTCONF uses data and operations or RPCs for resource types within the RESTCONF URIs. This figure shows a JSON formatted RESTCONF data and RPC operation and their associated URIs. As you can see here, we have two parts, data part and operation or RPC part, and here we have the URI. Okay, a module my interface, namespace, container, and after that list interfaces. We have some key name, leaf name, and also leaf admin status. I explained about the leaf previously. And after that, this is the part of RPC. Okay, and here we have the URI RESTCONF operation, my interface, flap interfaces. Okay, as you can see, flap interfaces. This is the flap interfaces, and the URI here is the interfaces, as you can see. Actually, this figure shows JSON RESTCONF data illustrating containers and lists with URIs. Okay, as you can see here, we have a container interfaces. Okay, this is the JSON container, list interfaces, a key name, and again leaf name, type is a string. Alright, this table shows the RESTCONF API CRUD operation, get, post, put, and delete, and associated URIs. For example, you know that we have the operation of get for the gets a resource. We have the operation of post, create a resource or invokes an operation, put, replace a resource, delete, removes a resource, and here we can see the URIs for these operations. Alright, now let me to compare the NETCONF and also RESTCONF. In many respects, NETCONF and RESTCONF are very similar. They both use the Yang data model and Yang development kits. They both are client-server based, with the controller being the client or the initiator and the server or receiver being the network element. They both use IETF Yang library to either discover server capabilities, NETCONF, or list the features the server support, RESTCONF. NETCONF and RESTCONF both use the concept of data stores, but RESTCONF uses the data store defined in the NETCONF. This figure shows a stack comparison of NETCONF and RESTCONF. As you can see, there are many similarities, especially in terms of Yang. As you can see, NETCONF support only the XML, but RESTCONF support both XML and JSON, but about other features they are same. Let's consider some of the differences between the NETCONF and RESTCONF. NETCONF was developed first in 2006 using XML encoding, and it uses SSH as a transport protocol. RESTCONF was developed approximately 10 years later to support both XML and JSON encoding, and it uses HTTP as a transport protocol. NETCONF can deploy across multiple devices by using a network-wide transaction. RESTCONF, on the other hand, has no concept of a transaction. A RESTCONF call uses HTTP post, HTTP put, update, or delete methods to edit data resources represented by Yang data models. NETCONF includes the concept of a lock to stop operations while editing the configuration in the candidate data store. RESTCONF does not provide the concept of a lock. Changes are directly applied. This figure illustrates the TCP/IP network frame format, showing where NETCONF, RESTCONF, gRPC, and Yang are present within the IP packet. Alright, now let me to explain a little about the IETF, OpenConfig, and also Cisco Yang model. Yang data models are developed by industry standard bodies such as the IETF and OpenConfig or specific vendors such as Cisco. About the IETF, the Internet Engineering Task Force is an internet standard body that develops open standards through open processes. The IETF is a large international group of network designers, operators, and vendors and researchers who are focused on the evolution of internet architecture. Their technical work within the IETF is done in working groups organized by topic into several areas. The Yang Model Coordination Group, for example, has been spending time on the inventory of Yang models in the industry, tooling aspects, training and education of NETCONF, Yang, Pyong, and the model coordination for the IETF. IETF data models are available on GitHub at https://github.com/yang models/yang. About the OpenConfig, it is a group of network operators working on developing programmable interfaces and tools for managing networks in a vendor-neutral way using software-defined networking concepts and model-driven management and operations. OpenConfig focuses on building consistent sets for vendor-neutral data models written in Yang to support operational needs and requirements from various network operators. The data models are developed by OpenConfig are compiled from third-party modules that use OpenConfig requirements. The developed Yang data models combine both configuration and operational data with support from multiple routing vendors such as Cisco, Juniper, and Arista. OpenConfig collaborates with standard bodies and network equipment manufacturers. The goal is for the developed data models to become industry standard interfaces that are widely adopted. OpenConfig data models are available on GitHub at https://github.com/openconfig/public. About the Cisco Yang models, a Cisco Yang model is a collection of Cisco native, IETF, and OpenConfig Yang models that can be used with Cisco-based platforms. Cisco has Yang models that are specific to iOS XR, NXOS, and iOS XE Cisco platforms, divided as subdirectories on GitHub. Each subdirectory has further OS platform information in a README file. Cisco data models are available on GitHub at https://github.com/yang/tree/master/vendor/Cisco. Alright, now let me to explain a little about the model-driven telemetry. Model-driven telemetry is a new concept in network monitoring. It involves continuously streaming data from network devices to subscribers using a push model and providing real-time configuration and state information. You can define what data you want to subscribe to be using standard Yang models and the NETCONF protocol. Structured data is published at a defined cadence or as things change based on the subscription criteria and data type. Third-party application can be used to collect data for monitoring and troubleshooting. Telemetry application subscriptions and their updates are transmitted over the NETCONF protocol. A NETCONF session is established using an SSH session to a network device. About the streaming telemetry data, it can be used for analysis and troubleshooting purposes to maintain the health of the network. Streaming telemetry allows users to direct data to configured receivers, where DevOps engineer can use the real-time operational information to find problems, look into issues, and optimize networks. Using traditional models for collecting network data limits scalability and efficiency. Network administrators have been using tools like SNMP and CLI to get operational data from routers and switches for years. However, these methods do not provide automation and do not make it easy to gather useful data from network devices. One of the limitations is the use of the pool model, in which a client must request data from network device. The pool model does not scale when there are several network management stations within the network. A push model continuously streams data out of the network device and sends it to the client. Telemetry makes the push model possible and enables near real-time access to device monitoring. There are two areas where streaming real-time telemetry data is useful. First, about the traffic optimization. Second, about the preventing troubleshooting. About the traffic optimization, when things like link utilization and packet drops in the network are occurring quickly, traffic optimization allows for traffic rerouting, adding and removing links, and making modification to QoS policies. This is faster than with SNMP polling interval and enables quicker response time. This is the first benefit of real-time or streaming real-time telemetry, that we call it traffic optimization. The second benefit is the preventing troubleshooting. This type of troubleshooting helps detect and avoid failure situation faster after problematic network events occur. Okay, let me to explain about three methods of streaming telemetry. First, model-driven telemetry. It provides a mechanism to stream data from a model-driven telemetry capable device to a receiver. The second, cadence-based telemetry continuously streams operational statistics and state transition at a configured cadence or time frame. And third, policy-based telemetry streams data to a receiver using a policy file that defines the data, to stream and the frequency for getting the data. You know that telemetry is an automated communication process by which measurements are collected and transmitted to receivers for monitoring of the data. Model-driven telemetry replaces the need for periodic polling of network elements using SNMP. Instead, it involves a continuous request for information to be delivered to a subscriber or receiver that has an established session with the network device. Data is received either periodically or as objects change via a subscribed set of YANG objects. In RFC 6241, Network Configuration Protocol or NETCONF explains a YANG push model, which is a subscription and push mechanism for access to YANG database. The YANG push model encompasses all of the data in the configuration and operational databases using the YANG model on the network device. However, a filter needs to be used for the data, as the subscription to all data is not supported. All session is telemetry use NETCONF sessions, which impose any session limitation specific to the NETCONF implementation. High availability in telemetry for NETCONF sessions uses SSH to the active switch or a member in a switch stack. If a NETCONF session is broken, a new NETCONF session must be established, including sessions that carry telemetry subscriptions. About the subscription to stream data in model-driven telemetry, the client application requests a subscription to a dataset in YANG from the network device. A subscription is an agreement between the subscriber and the subscription service that describes the data to be pushed out. The subscription service allows clients to subscribe to the desired YANG data models, and then the network device pushes the data to the receiver per the agreed upon subscription model. There are two types of subscription: periodic and unchanged publication. This figure illustrates subscription in a model-driven telemetry. Let me to explain about two types of publication: the periodic publication and also unchanged publication. About the periodic publication, the subscriptions that are periodic are streamed out to the receivers at specified intervals, such as every 5 seconds. With periodic publications, the network device continuously sends data for the lifetime of that configured subscription. A typical example where this type of periodic subscription is useful is for receiving data from PDU counters on a device. This figure shows sample output from the show telemetry IETF subscription command using a period of the 10 seconds. The period configuration in this figure is for time and is in a centisecond, okay, which is 1/100 of a second between updates. About the unchanged publication and unchanged subscription streams out data only when a change in the data has occurred, such as when an interface or a neighbor relationship goes down. This type of subscription is useful for when a data value changes occasionally, but the information needs to be sent in a timely manner. An unchanged subscription capability must be described in a Yang module definition in order to prevent erroneous association to a Yang subscription. It is not recommended to use an unchanged subscription for frequently changing data values such as counters incrementing on an interface. Alright, now let me to explain about two approaches, dial-in approach and dial-out approach. In dial-in mode, network device listens until the receiver dials in and sends the initial SYN packet to start the TCP connection. After the initial TCP connection is established, the network device pushes data out to the receiver at the configured interval. The network device acts as the server and the receiver is the client. Don't let the direction of the SYN packet throw you off, as there is no polling mechanism in model-driven telemetry. The dial-in mode of the subscription is dynamic and terminates only when the receiver cancels the subscription or when the session is terminated. Dial-in mode uses a single channel to communicate via a single transport and protocol for both configuration data and streaming operational data. Here are two examples of methods to request sensor pass in a dynamic subscription. For example, OpenConfig RPC and also iOS XR MDT RPC. First, about the OpenConfig RPC, the subscriber RPC command is used to specify sensor pass and frequency. A subsequent cancel RPC command is used to remove the existing dynamic subscription. About the iOS XR MDT RPC, with iOS XR RPCs are used to subscribe or cancel configured subscriptions. The sensor pass and frequency are part of the telemetry configuration. About the dial-out approach, with dial-out mode, a network device dials out and sends the initial SYN packet to start the TCP connection to the receiver. This is the default mode of operation. In this mode, the network device acts as the client and the receiver acts as the server. The network device continually attempts to establish a session and stream data to the receiver that has a valid subscription. The dial-out mode of subscription is persistent, and if a session terminates for some reason, the network device continuously tries to establish a new session with the receiver every 30 seconds. When using TCP dial-out, open a TCP socket on your receiver and the network device starts the three-way TCP handshake and starts pushing telemetry data across the session. No complicated programming libraries are required on the receiver. If you are using Python, you need a simple bind command for the port. TCP dial-out takes advantage of the benefits of TCP, such as reliability, fragmentation, and reordering, and is a great place to start with model-driven telemetry.